Hi friends, I hope you are doing well. Myself Abhishek Tripathi, I am going to share another set of interview questions which was asked in the Fresh Gravity Data Engineering interview questions. So I have already shared two set. So I am going to share another set with solution what I have done. So keep watching my video. So interviewer asked me, have you worked on the incremental data? So I simply told, yes, I have worked. I worked on the incremental data. I have loaded this. So he asked me how you have done what how you have done. So I told him in my projects we are basically there are two major data source. First is the file source and second is JDBC source. If I'm pulling from the data from a JDBC source, then source contain data column based on the source contain date column, and based on that column I am pulling data. I pull data on there. Another question he asked me, sorry, another answer I have given for the files which I'm receiving from the different source. So if I am receiving incremental file from the source, the while loading into first layer, we will add year, month, day, and hour partition column, and based on that, the latest partition, I'm going to pull the latest record for our my data consumption in my project. So another question he asked me: suppose you don't have any date column in source file as well as JDBC source, and you are and source also, and whatever source you are receiving file also you're not sure if that file contain the incremental data only, then how can you identify that these are the delta record and we have to ingest these are the delta records. Suppose I have a JDBC column. मेरे पास एक ओरेकल डेटाबेस है, उसमें पर डे डेटा लोड होते हैं. कल तक का मैंने डेटा लोड कर दिया और आज का डेटा मुझे लोड करना है, बट हमारे पास कोई डेट कॉलम नहीं है जिसके बिहाफ पे मैं उस रिकॉर्ड को डेटा को मैं इंजेस्ट कर सकूं, उसको डेल्टा डेटा मानकर इंजेस्ट कर सकूं. या फिर हमारे पास जो फाइल आती है, एक सोर्स से हमें पता चलता है कि फाइल हमारा इंक्रीमेंटल है, कि दूसरा जो सोर्स है उसमें ये नहीं पता है कि हमारा इंक्रीमेंटल है. हमें वही रिकॉर्ड लोड करना है जो आज की डेट में अपडेट या इंसर्ट हुए हैं. तो उस केस के लिए हम क्या करेंगे? सोल्यूशन. सो व्हेन डीलिंग विद अ सिनेरियो वेयर देयर नो एक्सप्लिसिट डेट कॉलम इन द सोर्स फाइल or JDBC source, to identify delta record you need to rely on the alternative strategy to determine which record are new, are updated or deleted. Here are few approach I'm going to give you. So first is hashing and checksum comparison. So generate a hash or checksum for the each record based on the its content. Compare the hash value between the new data and the existing data in your target storage. If the hash is different, the record has changed. If it is same, the record is identical. So implementation stage, how I'm implemented on this. So first generate a hash column. So create a hash or checksum of the relevant column in the both source and the target also. So here you can see that I have imported library like PySpark SQL function and imported SHA2 and concat wise and df source and this is my source. I'm going to read the data. I'm going to create one more column, add one more column in source df source in with column. I will record hash. I will give the name as record hash, and I will use SHA2 and concat wise to create a one more column with this help on this. And same way I will do for the uh, target also. Once it will done, then I will make a compare hash. I will compare the hash whatever given. So perform the left anti join to find record in the source that are not present in the target. So this way we can get the delta data. Another way, second way is full outer join comparison. So perform a full outer join between the new data and existing data on the primary key. So every table has if you get the file, are you getting for data from the JDBC source, चाहे आप JDBC से डेटा लो या फिर फाइल से डेटा लो, सो उसमें की कॉलम तो होगा ही बेस्ट साइड, आइदर एक कॉलम पे आइदर कॉम्बिनेशन ऑफ वन आर मोर or two or more column, either one column. So identify record that are only present in the source, that is a new record, only in target, that is a deleted record. That means we are not going to ingest a particular data record on there, and are in both but differences, that is a update record. So how I can implement this? So I will apply the full outer join here. For form a full outer join on the primary key df, I will give the name, and based on the primary key I will create a one data frame, and through that data frame I will identify delta record. So use condition to identify which record are new, updated, or deleted. So here you can see that df dot new record df full dot filter, whatever I have created data frame I'm going to use here. Dot filter, the primary key is null. What this primary key is null, through that I will identify this is the new record. How can I identify this is the updated record? So you can see that primary key is not null, and primary key is not null, and full source df and source for source and df target tgt should be matched. This way I can do the things. Otherwise I can use this df delete which is not which is available in target, and we with this there is no update, or this is not a new record, so I'm going to remove that record from the main df. Then I will use and I'm going to use this final one to insert the record. So another question he asked, have you been worked on the ideal data, means full load? Let's assume 1 billion record in your source, and you need to handle all these records and load into the target. So then suppose you will face performance issue, then how can you handle to once he asked the question, so I simply told I work with the ad hoc data. Ad hoc means full load on there. So I'm just now we're going to the now I'm going to the performance part. How can I manage? Hence, there are different way I can manage handling the full load in of 1 billion record efficiently in data processing environment like Spark can be challenging due to the large data volume. However, there are several strategies you can employ to the optimize performance and manage the load efficiently. So I'm talking about right now file part. So first, whatever sub sub partition the data. First approach what will be the partition data and partitioning in the Spark. Whatever is there, I'm going to do the partition to Spark. Ensure the data is well partitioned to leverage the Spark distribution computing capabilities. Another, partition by key. If possible, partition the data based on the key that relevant to your processing logic, like date column or id column. So this minimize data shuffling and improve the parallel processing on there. So right now you can use this repartition, and based on the particular partition column you can create. Now another approach is efficient data source format. So either you can use Parquet file format or ORC file format, because they are using columnar storage format like which are more efficient for both read and write operation. So you can do this way. df.write.parquet output path and mode, what is your required, that is your way. And another is comparison. Use efficient comparison algorithm like Snippy when writing to these format when writing to these format. Now third is incremental loading. So for like a batch processing on there, so dividing the 1 billion record into the smaller batches and load each batch incrementally. This can help managing memory usage and prevent overwhelming the cluster. So like you have given the batch sizes 1 lakh. In every batch it will load 1 lakh record. So I will run down loop. In the loop I will give the what is the count on the df dot count, what is total count in the particular df, and then I will use a batch. I will give the batch size. Then for batch, df dot limit dot batch size, whatever batch size is there, then offset I will give the I here, and df. Then what will I do? Then I will write in the Parquet path in the in append mode. Now another optimization part is broadcast join. So a small dimension table, like one is the small dimension table is there. So if your operation involve joining a large data frame with a small one, consider broadcasting the smaller table to avoid a costly shuffle. Suppose your requirement is that you have to pull the आपकी requirement ये है कि आपको source से huge amount of the एक फाइल मिलेगी जो उसका काउंट ज्यादा होगा या फ्यूज अमाउंट होगा, और उसमें क्या होता है कि आपको ज्वाइन करना पड़ेगा एक किसी टेबल के साथ, मतलब कोई स्मॉल टेबल के साथ, कि हमें कुछ कॉलम उससे इंपोर्ट करना है, जैसे कि हमारा डिपार्टमेंट नेम हो गया, हमारे एम्प्लॉय का डिटेल आ गया, हमारे पास फाइल हो गई 1 GB के ऊपर हो गई, 10 GB के ऊपर हो गई एम्प्लॉय की, और उसमें एम्प्लॉय आईडी है, डिपार्टमेंट आईडी है। हमें क्या करना है कि डिपार्टमेंट नेम भी लेना है, बट वो हमारे पास ऑलरेडी एम्प्लॉय डिपार्टमेंट मास्टर पड़ा हुआ है। Based on the ID column we can going to join and give the things. So in this case what we will go for that, we can use a broadcast join here. So if your operations involve joining a large data frame with a small one, on consider broadcasting the smaller table to avoid costly swapping in this case while before writing. After that, and there is another mechanism, caching intermediate results. So caching the data frame. If your processing involve multiple stages, cache intermediate result to avoid recomputation. That now number six, efficient resource allocation. So while we are so cluster, what is the cluster sizing? Ensure your Spark cluster has adequate resource memory CPU core to handle the large volume of data. Before submitting you have to tune the cluster size, net tuning executor and other things, tuning executor, adjust the number of executor memory and core based on the size on there. Now another question, I'm sorry, another solution, avoid white transformation. So minimize shuffling. So avoid operation that cause white transformation such as group by and join unless necessary. When required, try to optimize them by reducing the number of keys or using partition. Either you can use map partition. For example, transformation consider map partition which operates on per partition based basis and can reduce overhead on there. And now another question, another solution, eight number, it's whatever. Another solution, handling skew data. So if you get the skew data, you can use salting technique to avoid the this type of issue. If you have a skew data, some keys have significantly more record, so use the salting technique to distribute the load more evenly across partitions. So I have given this code df dot column with column I have created, I'm creating the salting key, concat and lit, I'm giving the all things this way. I'm going to create a salting key and then we'll do for their our purpose. Now another part is monitoring and debugging. So monitoring job process in Spark UI using the to identify bottleneck such as stages that are taking too long or heavy struggling tasks. And after that, the another point is job logs. So check the logs for the any error of or warning that might indicate resource contention or inefficiency. Now another part is checkpoint. Checkpoint is also like look at checkpoint is also very important factor um, in as per performance part. So checkpointing data for extremely large data sets or long running jobs, consider checkpointing the data to stable storage to avoid reprocessing in case of failure. So suppose if you are working with a JDBC, you are dealing with a JDBC source, pulling data from JDBC source. So when loading large data set from a JDBC source like database, Oracle, MySQL, Postgres, MS SQL Server into the Spark, handling 1 billion records efficiently requires careful consideration of several factors to optimize the performance. Here, how you can approach this. So first use partitioning for a parallel record. So partitioning the JDBC source, instead of pulling the entire data set in one go, partition the data on the database side to allow parallel read. This can be done using the partition column, lower bound, upper bound and number partition option in Spark JDBC method. So you can see that here JDBC URL, whatever your database using, that you have to give. Then JDBC property, you have to give the user, password, driver. Then you have to define the partition parameter. So partition column like ID, and then I have to define the lower bound and upper bound, and number of partition I have to give. So Spark DF, then after going to read from this particular location, the spark.read.jdbc, now you have to give URL table name, column, lower bound, upper bound, number of partition, properties, whatever given on there. So this way you can come you can do one do. And another things, partition by a data sequence. If your table has a date column or sequential ID, use it for the partitioning to ensure even distribution across the partition. Second, optimize JDBC phase size. So tuning phase size, adjust the phase size parameter to control how many work rows are fetched at a time from a database. This can reduce the number of round trip to the database, improving the performance. So you can see the JDBC property and phase size. You have to give this one. Then now another part, load in batches. So batch processing, whatever I told for the earlier for files. So instead of loading all 1 billion record at once, consider the loading the date in small batch, and you can use a loop or script to load batches based on the data range, IDs, or other logical partition. So you have to use this code, whatever I have written here right now. Now I'm going to the another part, another solution, push down filter and projection. So push down filter condition directly to the database to minimize the amount of the being amount of the data being transferred. Only the necessary record are fetched. So you can use this code, whatever I have given. Now another part is that column projection. Select only the column you need instead of fetching the entire table. These reduce data transfer memory uses. So I will let you know one scenario what I faced. So while working with my previous company, on there is a one table that is near about 10 cr, one near about a huge 1 TB or 2 TB, 1 TB or 2 TB साइज फाइल, साइज टेबल ऑन देयर. सो हम लोग उस टेबल को रीड करते थे और उससे और दूसरे टेबल को ज्वाइन करके हम डेटा फेच करते थे. बट होता क्या था कि वो जॉब 1 घंटे और 1 घंटे 10 मिनट रन करने के बाद हार्ट बीट टाइम आउट एरर करके वो फेल हो जाता. सो मीन्स हार्ट बीट टाइम आउट मीन्स नथिंग बट अ memory issue on there. So what we have, after analyzing the analyze all the things, what we have done, whatever necessary column, जितने जितने जरूरी कॉलम है उन्हीं को लेंगे. और अगर कोई कंडीशन हम बाद में लगाने वाले हैं तो बिफोर डूइंग द ऑल ऑपरेशन वो पूरे कंडीशन लगा करके वो हम डेटा को फेच करेंगे. उसके बाद उस डेटा फेच करके उसको कैसे करेंगे, उसके बाद जो भी ऑपरेशन परफॉर्म करना होगा, भी जो भी जरूरत चीज होगा, वी कैन डू आफ्टर दैट. Now, another question is optimize resource allocation. So, tuning executor. So, ensure that your Spark cluster is adequately size of the job, especially in terms of the memory, CPU core, and the number of executor. So, you can see the number of executor 100, memory is 8G, executor core is 4 on there. So, now, sixth part is caching intermediate result. So I told you that if you need to perform multiple operation on the same day, consider caching. Consider caching the data frame after loading it into 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 the JDBC source. So you can so I can use df.cache. Now another question, another part is what solution is there, handling skew data, skew management. If your partition column is skewed resulting the in an even partition, consider adding a salting column or adjusting partition boundary to balance the load. So another part is optimization part for the JDBC source. Use database specific optimization. So ensure that the database has a optimize for the read performance by using appropriate indexes on the column used for the partition and filtering. And another part is database configuration. Work with your database administrator to ensure that the database configuration like connection pools, setting, memory location is optimized for the high value read operation. So these are the three questions I have. I'm given the answer in this video, and I will give the another set of the answer in evening. So I hope you are getting the good question and preparing the things. And if you have any other solution for these three questions, you can give me your suggestion in comment box. I'm requesting you, please like and subscribe my channel. Thank you very much.